It is 1995 AL, first structured essay question. First structured essay question. They have given us a metal plate. They have given us a metal plate, a square metal plate. So as it is a square metal plate, right? All the four sides are equal in length. Length of this side is simple A. Length of this side is also simple A, simple A, and simple A. It is saying that there is a hole in it. That's a hole in it. The hole is also square. So it means if this length is simple B, this is also simple B. Right. First of all, please draw this figure. First of all, please write the heading as 1995 AL first structured essay question and draw this figure. I have given you more than enough time to try the question. Start. The first question, what is the best laboratory instrument that can be used to measure simple T? So T is the thickness. This thickness will be very small. So it may be in 1 or 2 millimeters. The best instrument to measure such a small length is micrometer screw gauge. Therefore, the answer for simple A question, the best instrument to measure the thickness is micrometer screw gauge. Micrometer screw gauge. Then let's go to simple B question. Read simple B question. An important check has to be made before taking a measurement using the above instrument. What is it? An important check has to be made before taking a measurement from the above instrument. What is it there? We should check whether the instrument has a zero error. Is right? It should be checked. It should be checked whether the instrument has a zero error. Whether the instrument has a zero error. Whether the instrument has a zero error. Simple B question. An important check has to be made before taking a measurement using the above instrument. What is it? So it should be checked whether the instrument has a zero error. If you have, let's say, in the exam, let's say they have given only one line. If they have given 2 lines, we can add one more sentence. So let's imagine that there are 2 lines are given. So please add one more sentence to the answer for simple B. Please write. Thimble is rotated. Thimble is rotated until the spindle touches the anvil. The thimble is rotated until the spindle touches the anvil. Right? So how do we check a zero error here? How do we check a zero error? We rotate the thimble until the spindle touches the anvil. So if the instrument does not have any zero error, we will say something like this. We will say the main scale baseline, the main scale zeroth line, and the vernier circular scale zero line like this. Right? So please write. Please draw this figure as a knot. So answer is O. What is the answer? It should be checked whether the instrument has a zero error. And we have added one more sentence. The thimble is rotated until the spindle touches the anvil. After that, write knot. When the spindle touches the anvil, when the spindle touches the anvil, comma, if the zero lines of the two scales are appeared as shown in the following figure. Zero lines of the two scales are appeared as shown in the following figure. Comma, then it is confirmed that the instrument does not have a zero error. If the zero lines of the two scales are appeared as shown in the following figure, comma, it is confirmed that the instrument does not have a zero error. It is confirmed that the instrument does not have a zero error. Draw this figure here. Draw this figure. So this is an additional thing. Complete. Right. If this is disconnected, please use the same username and password to rejoin. Let's go to the next question. Simple C. You are given a vernier caliper to measure simple A and B. Which part of the instrument you would use to determine simple A? Simple A means this length. To measure this length, we use external jaws. So answer for simple C, for the simple A measurement, we use external jaws. External jaws. To measure simple B, we have to use internal jaws. Internal jaws. Complete. Right. Simple D question. What is the most suitable laboratory instrument that can be used to measure simple N? Simple mass of this is very small. The mass of the metal plate is very small. The best instrument to measure the mass of such a small mass is chemical balance. Chemical balance. So answer for simple D equation is chemical balance. It is the most suitable instrument to measure the mass of such a small mass. Right. Then simple E equation. Write down an expression for the density of the metal in terms of M, A, B and simple T. So look at board dear. Look at board. This is a metal plate. If there is no hole, the cross section area is A into A. But due to the hole, some amount of metal is removed. So only this part is the metal. Only this part is the metal. The rest is the hole. So therefore, if this length is simple B, this is also simple B as they have given, right? So what is the cross-section area of the plate here? Cross-section area of the plate. Cross-section area of the plate is cross-section area of the bigger plate minus cross-section area of the hole. So cross-section area of the bigger plate is length into B, A into A. Cross-section area of the hole is B into B. Therefore, this is the volume of the metal area. So A into A is A square, B into B is B square. So this is the cross-section area. So in the exam, we cannot draw a figure because this is a structured essay paper. There will not be enough space to draw the figure. But here now we are discussing this question. So please draw this figure and write down that equation. After that, we want to find the volume. After that, we can find the density. Start. Right. After that, we can find the volume. So we are discussing, today we are discussing 1995 AL first structured essay question. So which is given from it's a combination of measuring instruments and mechanics. Right. So what is the, we had simple equation. What is the volume there? The volume of the metal section. Volume of the metal. Volume of the metal, I think you remember this equation from O level. Volume of a uniform object is equal to cross-section area into length, or here it is thickness. Here it is thickness. So what's the equation here? The volume of a uniform object is equal to cross-section area into length, or cross-section area into height, or cross-section area into thickness. Same. Thickness, height, length, same, right? So cross-section area is simple A square minus simple B square into thickness is simple T. So this is the volume of the metal, start, or the material. Quick. Now we can easily write down an expression for the density. We can easily write down an expression for the density. We know that density equals mass over volume, right? So mass of the metal piece is simple M. Volume of the material is A square minus B square into simple T. So this is the answer for simple A. In the examination, we have to write this equation directly. We cannot draw figures. We cannot write equations like this because this is a structured essay paper. There will not be enough space. Complete. Right, then let's go to the next part of the question. Simple F. The thickness simple T was measured 5 different places of the sheet and the values obtained are given below. So what are the 5 values for the thickness there? 1.10 millimeter. Simple F question. They have taken several readings to find the thickness of the sheet. The first reading is 1.10 millimeter. Then they have measured the thickness at another place of the same plate. Then the thickness reading is 1.11 millimeter. Thickness of the same plate at a different place is 1.12 millimeter. 1.12 millimeter. Then thickness of the another place of the sheet is 1.11 millimeter. Right. Under that they have asked 3 questions. What is the least count of the measuring instrument? All the measurements are up to 2 decimal places in millimeter. See, 1.10, 1.11, 1.12, 1.11. So there are 2 decimal places in millimeters. Therefore, answer to the first question, least count should be 0.01 millimeter. Then only we can measure all these measurement 1.10, 1.11, 1.12, 1.11. Therefore, the least count should be 0.01 millimeter. Complete it here. Complete it. Right. Then second question. What is the second question? Calculate mean thickness of the sheet. Mean thickness means average thickness. So what is the mean thickness of the sheet? Mean thickness of the sheet is equal to sum of all the four readings, T1 plus, T2 plus, T3 plus, T4 divided by 4, divided by number of readings. So T1 is 1.10 plus 1.11 plus 1.12 plus 1.11 and all the things divided by 4, divided by 4. So this is the average thickness. Can you find it here? Can you find the average thickness without my help? We have to add these four numbers, 1.10 plus 1.11 plus 1.12 plus 1.11. So if you add them all, you will get 4.44. If you add all these numbers, you will get 4.44 divided by 4. So then you will get 1.11 millimeter. So that is the average thickness, right? Then let's go to the next part of the question. Up to how many decimal places would you give the answer calculated above? Explain why. I'll keep the answer up to 2 decimal places in millimeter because least count is up to 2 decimal places in millimeter. So please write the answer for the third question. Please write the answer for the third question. The above answer is kept up to 2 decimal places in millimeter. The above answer is kept up to 2 decimal places in millimeter. Up to 2 decimal places in millimeter. Leave a line and write reason. Leave a line and write reason because the least count is reason because the least count is only up to 2 decimal places in millimeter. Because the least count is only up to 2 decimal places. 2 decimal places in millimeter. So if you use the measuring instrument, if its least count is only up to 2 decimal places in millimeter, any measurement taken from that instrument should be kept only with 2 decimal places in millimeter. That's the reason, right? What about the next question? Simple G. To determine the volume of a sheet, students suggest to determine the volume of the sheet, a student suggests immersing the sheet in water and measure the volume of displaced liquid. State why this is not so accurate compared to the value calculated above. The reason is this volume is very small. This volume is very small. I'll explain the student's method here. The student's method is this. We can take a measuring cylinder, right? and let's say we have filled water. Let's say we have filled water up to 50 millimeter level. After that, I'm explaining the student's method. After that, right, we place the metal sheet inside this measuring cylinder. The metal plate is placed inside this measuring cylinder. So the volume of this metal sheet is very small. Therefore, most of the time, the volume of water will just slightly above the 50 millimeter line, for example, 50 millimeter line. So you will not see a huge difference in rise in volume due to the very low volume of the metal sheet. So you will get the volume of the metal sheet almost zero. Therefore, this student's method is not suitable. Student's method will be more suitable if this object, if this metal sheet has considerably larger volume, then student's method is okay. But here, the volume of the metal sheet is negligibly small. Therefore, the student's suggested method is not correct, not accurate. 4, please write simple G. Answer for the simple G, please write. The volume of the metal sheet is very small. The volume of the metal sheet is very small. Therefore, the volume of the metal sheet is very small. Therefore, there will not be considerable change. There will not be a considerable change. Considerable change. When the metal sheet is immersed in water, when the metal sheet is immersed in water, right? The volume of the metal sheet is very small. Therefore, there will not be a considerable change in the volume of water after the metal sheet is immersed. After the metal sheet is immersed in water. Right, so please draw this figure saying a knot. Please indicate this as a knot and draw these figures. Start. These figures will help you to understand the suggested method. Start. Right, then let's go to the essay question. Then let's try for the second essay question. Read. A box of mass 100 kilogram is to be raised to a vertical height of 1.4 meter by pushing it up an inclined plane. Right. So what is it? It is 1995 first essay question. First essay question. Let's try to discuss it. Right. So there is an inclined plane. Read the question. Read the question. They have given an inclined plane like this, right? They want a box of mass 100 kilogram is to be raised to a vertical height of 1.4 meter by pulling it up an inclined plane and then to be transferred over to a horizontal conveyor belt as shown in the figure. It is found that minimum force 640 Newton is necessary to move the box along the inclined plane, which makes an angle of 30 degrees with the horizontal. Right. So I am not going to draw the belt here. I'll draw the box and the other things. Right. Look at both them. This angle is given as 30 degree. Right. This height h is given as 1.4 meter. Right. They have not given any letters, so I'll mark the points as A, B, C. So A, B, C, AC is the inclined plane. Right. So there is the box. This box is moved with a minimum force. Moving something with the minimum force means you are moving it with the constant velocity. What's the meaning of moving with the minimum force? The minimum force required to move the object means the object is moving with the uniform velocity. So if I mark it as u meter per second, velocity of the object will always be u meter per second. From starting to the end, the velocity of the object will be u meter per second. So it means there is no change in kinetic energy. As the velocity is constant, as the velocity is very small, there is no change in kinetic energy throughout the motion. But there will be a change in potential energy. You see, the object has reached to a height of 1.4 meter. 1.4 meter. Therefore, there is an increase in potential energy. For this motion, it is said that it needs a force of 640 Newton. So when you apply a force of 640 Newton, the object is moved along the inclined plane with a very small uniform velocity. That's why it is said to be the minimum force. This object is not accelerated. Why is that? If we apply a 640 or 640 Newton. You have applied the force, but it is not accelerated. Why? Because there is a friction force. There is a friction force, F-R-I-C Newton. So when the 640 and friction forces are equal, the resultant force acting on the object along the inclined plane is 0. When the net force acting on an object is 0, it will be moved with a constant velocity. Whose law is that? Whose law is that? If the net force, if the resultant force, if the total force acting on a moving object is 0, it will be moved along a straight line path with a constant velocity. Whose law is that? Anybody? Anybody in the class? It is Newton's first law of motion. When there is no external unbalanced force acting on an object, it will be at rest or it will be moved along a straight line path with a constant velocity. Newton had mentioned about two objects in his first law. First one is a stationary object. The second one is a moving object. If you do not apply an external unbalanced force on a stationary object, it will be at rest. If you do not apply an external unbalanced force on a moving object, that object will be moved along the same path into the same direction with the same velocity. So at the beginning, he may have given a somewhat larger force to start the motion. After that, he continued the motion with the constant velocity. Right? So it means the resultant force acting on the object is 0. When the resultant force acting on an object is 0 on a moving object, it will be moved with a constant velocity. So huge theory is there behind the question. Right. So first of all, please draw this figure. Please draw the figure in a very big size. Start. Draw it in a bigger size. You can unmute the mic and give me your answers, right? You can talk to me directly, no problem. The question asks Roman number 1. What is the total work done by the above applied force in pushing the box up along the inclined plane? So they ask us to find the work done by this external force. Please let me mark this as an external force. An external force given by us on the object. Right, so Roman number 1. Roman number 1. Work done by the, please don't write, please don't write, wait a minute. Work done by the 640 Newton force. We know that force, work done by a force is equal to force into displacement. Force into displacement. We know that force is 640 Newton. The displacement is AC. The object is moved along the AC inclined plane. So, but we don't know the length AC. That's the case. We don't know the length of the inclined plane. So we have to find the length of the inclined plane. To find the length of the inclined plane, I can use this equation sine 30. If you consider this right angle triangle, sine means opposite side BC divided by hypotenuse AC. Opposite side divided by hypotenuse is sine. Therefore, sine 30 equal BC divided by AC. Sine 30 is half. BC is 1.4 meter. AC is the length that we want to find. So I'll write it somewhere here. If you take AC to this side by cross multiplication, and if you take number 2 to the other side by cross multiplication, you will get that AC means 1 into AC equals 2 into 1.4. So it means AC length is equal to 2.8 meters. So first of all, we have to find the length of the AC inclined plane. After that, we can put that value here. 640 into 2.8. Right? This can be easily simplified. 642.8 can be written as 28 over 10. When you write it like this 0 and this 0 can be cancelled out. Then you get 64 into 28 is the amount of work done by the external force. Complete. Okay. So what is the amount of work done by this external force? 64 multiplied by 28, that is 1792. 1792 joules. Who got this answer? Who got this answer? Abdurham, Atika, Asma Lafir, Oshadi, Gimhan Vijayabandara, Krisha. Any other students who got this answer? Okay, almost all the students got the answer. Havini, very good. Atika, right. Let's go to the second part of the question. What is the corresponding increase in the potential energy of the box? Increase in potential energy of the box. How do you find it? Roman number 2. Roman number 2. The increase in potential energy. The increase in potential energy of the box equals mgh. So as I do not have enough space to write here, I'll put the X mark here and I'll do my calculation here. Mass of the box 100 kilogram, G is 10, H the vertical height 1.4 meter. 1.4 meter. 1.4 into 10 is 14. 14 into 100 means 1400 joules. So this is the increase in potential energy of the object. Increase in potential energy of the object is this. Complete. We had done a work of 1792 joules, but the increase in potential energy of the object is 1400 joules. Why is that? What is the reason for it? We had done a lot of work, but only less amount of smaller, it means the amount of increase in energy is smaller than the amount of work that we had done on the box. Right? What is the reason for it? The reason is there is a friction force. Some amount of energy given to the box, some amount of work done on the box is wasted due to the friction, or is used to do overcome the friction force. Right? Let's check the next question. Roman number 3. If the value obtained in 1 and 2 are different, explain the reason for it. Please write. Please write. Some amount of the work done by the 640 Newton force. Answer for Roman number 3. Answer for Roman number 3. Some amount of work done by the 640 Newton force. 640 Newton force is used to do work against the friction force. Some amount of work done by the 640 Newton force, 640 Newton force is used to do work against the friction. Is used to do work against the friction. Full stop. Full stop. Within brackets, some amount of provided energy, within brackets, some amount of provided energy is wasted due to the friction. Some amount of provided energy is wasted due to the friction. Clear? So we had provided an energy of 1792 joules. Some amount of energy is wasted due to the friction. Therefore, the gain of energy of the object is only 1400 joules. Got it? So if you want to repeat, please tell me. If you want to repeat any of the sentences, please ask. I can help you. Are you sure that nobody wants to repeat? Right, so leave a line and write therefore there is a difference. Therefore, there is a difference between the work done on the object. Therefore, there is a difference between the work done on the object and increase in potential energy of the object. Therefore, there is a difference between the work done on the object and the increase in potential energy of the object. And the increase in potential energy of the object. Clear? Right. Then read the next question. Please read the next question. Roman number 4. Read. Calculate the coefficient of friction between the box and the inclined plane. Calculate the coefficient of friction between the box and the inclined plane. So before we calculate the coefficient of friction, we have to find the friction force. First, we have to find the friction force. Then only we can find the coefficient of friction. Right? So please write, put Roman number 4 and write, according to the law of conservation of energy, according to the law of conservation of energy, according to the law of conservation of energy, comma, according to the law of conservation of energy, comma, leave a line and write this equation. Work done by the 640 Newton force equals increase in potential energy plus work done against the friction force. Work done against the friction force. So what is the equation here? Work done by the 640 Newton force should be equal to the increase in potential energy of the box plus work done against the friction force. Complete. If you have any doubt, you can ask. Right. Work done by the 640 Newton force. Work done by the 640 Newton force is 1792. We have found it as 1792. Increase in potential energy, we have found it as 1400 joules. Work done against the friction force means friction force multiplied by displacement. Force into displacement is the work done by a force. So work done against the friction force means friction force into displacement. Right. Friction force into displacement. So let's take 1400 this side. 1792 minus 1400 equals friction force into displacement. Friction force into displacement. So 1792 minus 1400 means 392, right? We don't know what the friction force is. But we know that the displacement is 2.8. That is the length of the inclined plane. This is the length of the inclined plane. Right? Object is moved along the inclined plane. The length of the inclined plane is 2.8. Therefore, the friction force is acting for a distance of 2.8 meters. So just take 2.8 to this side. Then you get 392 divided by 2.8 equals friction force. So from this method, you can find the friction force. To find the coefficient of friction, we have to find the friction force first. Complete this. Write it. So if you divide 392 by 2.8, you will get 140 Newton. So finally, we have found that therefore the friction force equals 392 Newton divided by 2.8 means 140 Newton. So this is the answer. Complete it. Right, we have found the friction force. We want to find the coefficient of friction. We have found the friction force. Now we are going to find the coefficient of friction. Look at board. Right. Let's draw the inclined plane in a bigger size. This angle is 30°. If I draw the box like this, the weight of the box is acting vertically downward, mg, Newton. The normal reaction force given by the inclined plane acting like this, R Newton. If this is 30°, this angle will also be 30°. This mg force can be divided into two sections, which is known as resolving a vector into two components. The component towards the angle is cos mg, cos 30. And the force component away from the angle is sin 30, mg, sin 30. The box is moved up, the box is pushed up by a force of, I'll draw it in smaller size. This is pushed up by a force of 640 Newton. In addition, there is a friction force acting against the motion. We have found the friction force to be 140 Newton. R is the force given by the inclined plane to the object. The force given by the object to the inclined plane is mg cos 30. R is the force given by the inclined plane to the object. mg cos 30 is the force given by the object to the inclined plane. They are action-reaction forces. According to Newton's third law of motion, action force should be equal to the reaction force. Therefore, R and mg cos 30 should be equal in magnitude, opposite in the direction. It can be clearly seen from the figure. So we have to draw this figure. And we have to find that value of R. R equals mg cos 30. M is I leave as it is. I leave as it is. After that, we know that friction force. We know that friction force is equal to mu r, which is known as the coefficient of kinetic friction. We want to find it. We have found friction force as 140 Newton. We don't know the value of mu. We don't know the value of mu, right? We know we have found that R as m is 100, g is 10, cos 30 is root 3 divided by 2. So I'll put this value here, right? 100 into 10 into root 3 divided by 2. Please draw this figure, write down everything, and try to find the value of mu. Start there. Please draw the figure, right? And if you have any doubts, if you are confused with any of these points, please ask, right? You can unmute the mic or you can send me a message, I'll reply. So this is a live class, right? This is not a recorded class. Therefore, you can ask questions directly. If you have found the value of mu, please send me a message. Send me your answer. Zero, it's impossible. Check again. 0.16, 0.161. Any other answers? Gimhana? We can use cross multiplication to take the numbers to this side and this number to this side like this. So then we'll get 140 multiplied by 2. All these numbers comes to the denominator. 100 into 10 into root 3 equals mu. So we can cancel out this 0 and this 0. Right? Then we will get mu equals 2 into 14, 28, divided by 100 root 3. Who has obtained the answer up to this level? Anybody in the class? Atika Ramsan. Any other students? Abdurham, Shasley, Gimhana, Murlidharan, Asma Lafir, Danushan. Danushan, even you came to my land bridge class last week, right? Okay. How to simplify this here? What will be the value if you simplify this here? Square root 3 means 1.732. So that is 173.2. So 28 divided by 173.2, that is 0.161. So what's the answer? 0.16 is enough. Coefficient of friction does not have units, no units, right? Now let's go to the next part of the question. At the top of the inclined plane, the box is transferred instantaneously with a negligible small speed onto the belt, which is moving horizontally at a constant speed 4 meters per second. The box acquires the speed of the belt to 2 seconds after it touches the belt. What is the change in momentum of the box along the horizontal direction? I'm going to erase everything that I have written on the board. Therefore, please get a screenshot if you have not written it. Right, so I'll erase. Right, now the belt is moving with a certain velocity. At the time when the box is placed on the belt, the box will slip. The box will slide on the belt. So there will be a difference in velocity of the box and the belt. The belt is moving with the velocity of 4 meters per second, as I remember. Is it correct? Yeah. But initial velocity of the box is 0. So it means there's a gap. It means they slide on each other like this. They slide on each other. But after some more time, the the velocity of the box also become 4 meter per second. So belt is moving with the velocity of 4 meter per second. Box is also moving with the same velocity. The time taken for this change, is given as 2 seconds. Got it? Draw this figure here. Draw it. The first question, what is the change in linear momentum of the box along the horizontal direction? So simple. What is the change? Change in linear momentum of the box equals final linear momentum, M into V, minus initial linear momentum, M into U. Initial linear momentum, final linear momentum, 100 into final velocity. Mass into final velocity is the final linear momentum. Mass 100, initial velocity 0. Mass into initial velocity is the initial linear momentum. 100 into 4 is 400 minus 0 into anything 0. Therefore, the change in linear momentum is 400. The SI unit is kg ms minus 1. Complete. Then they ask us to find the force acting on the box and how this force originated. You see, when the belt is moving to the right hand side, box is at rest. So there is a sliding motion between the box and the belt. So when the belt is moving to this direction, if you keep your hand on the belt, you feel that belt is pulling your hand to that side. So this force is actually given by the friction between the belt and the box, right? So belt is moving to the right hand side, box is trying to be at rest due to its mass and inertia, right? So there will be a friction force into this direction. So first of all, let's calculate the friction force, right? To calculate the force acting on the box, I can apply F equals in me, right? So F equals mass is 100. Acceleration. Acceleration is increase in velocity divided by time taken. Increase in velocity means final velocity minus initial velocity divided by time taken. What is acceleration here? Increase in velocity divided by time taken. So final velocity minus initial velocity divided by time taken. Or you can use the impulse equation also. So F equals 100. Final velocity is 4. Initial velocity of the box is 0. The time taken for this process is only 2 seconds. So F equals 100 into 4 minus 0 is 0. 4 minus 0 is 4. Divided by 2 is 2. 4 minus 0 is 4. Divided by 2. 4 divided by 2 is 2. 2 into 100 is 200. Therefore, the belt needs a force of 200 Newton. Right? And this force, the force acting on the box is the friction force between the belt and the box. So they ask how this force comes. So please write, that is the force. This is the force between, this is the friction force between the belt and the box. Complete. There are many methods to simplify. Yes, you can multiply. I'm talking about the previous calculation. If you want to take root 3 up, you can multiply both by root 3. Then root 3 times root 3 will be 3, and the upper you will get the root 3 to the up. So yeah, that's possible. Yes. Uh, the friction force given by the belt to the box 200 Newton. According to Newton's third law of motion, the equal and opposite force should be given by the belt, given by the box to the belt. Let me explain it. Let me explain it. So I'm going to erase. If you want, please get a screenshot if you are not able to write anything. If you consider the belt and the box, I'll draw them by keeping a small gap so it's easy to mark the forces. When the belt is moving to this side, it gives a friction force to this side. So this force is 200 Newton. According to Newton's third law of motion, then the box should give equal and opposite force to the belt. So the box will give a 200 Newton force against the motion of the belt, against to the motion of the belt. So due to this force, due to this 200 Newton force, the velocity of the belt may be reduced. Therefore, we have to give an additional force of 200 Newton to the belt. That can be achieved, that can be given to the belt by connecting an electric motor to it. That's the easiest way, right? So it means something like this. Let's say there are this is a cylinder rotated by a motor. Let's say this is another cylinder rotated by a motor. So if you send a belt over the two cylinders like this, so this belt can be moved. Let's say before the belt is placed on the, before the box is placed on the belt, let's say only one motor is rotating. Now additionally 200 Newton is needed, so we can start the other motor also. So you can make some sensors and automated systems for this. Right, so for the answer for simple C part of the question, it's better if you draw this figure and write that additional 200 Newton force can be given to the belt by using an electric motor. That additional 200 Newton force can be given to the belt by connecting by using an electric motor. So that is the easiest way. That additional 200 Newton force can be given to the belt by connecting an electric motor. Please draw these two figures saying a knot. Saying a knot. Please draw these two figures. Draw these figures saying a knot. These two figures will help you to understand the story. Right, so we have reached to the end of the discussion of 1995 first essay quiz. So during this paper class, we have discussed 1995 paper, first structured essay question and first essay question. Now we are going to discuss light structured essay question. Light essay question given from given in 1995 paper. For my 22 A-level students, I have completed up to the light lesson. So I have completed units, dimensions, measuring instruments, mechanics, simple harmonic motion, sound waves, and light for my 22 batch. So let's discuss the light question also. Give me 1 minute, I'll send you the question to your WhatsApp group. Right? If you want to repeat any part, please send me a message saying I want to repeat that certain part. Right, look at board. Eileen is right. I think you have drawn these figures. Right, I'm going to discuss 1995 AL light question. Light essay question. light essay question. I'll read the question for you. Let's give a try. Angular magnification is a better measure compared to the linear magnification. In determining the magnification produced by an optical instrument. Briefly explain this statement. There are two magnification equations. First one, linear magnification. Height of the object divided, height of the image divided by height of the object. The second one is angular magnification equals angle subtended by the image on eye divided by angle subtended by the object, alpha divided by beta. Look at board there. You have learned those things in our light lesson. So if you consider an eye, I'll draw two eyes, two identical eyes, so it will be easy for me to explain. Two identical eyes, and I'll use the same object. For example, let's say an object is somewhere here. Let's say height of this object is 2 centimeters. Let's say this distance is 10 centimeters. When you draw it, the figure, it will be help for you, right? So height of the object 2 centimeters, distance to the object from the distance between the object and the eye 10 centimeters, for example. Then I'll take a light ray which goes to the optical center of the eye lens. Then an image is formed on the eye. So then an image is formed on the eye. You see, now image is smaller, right? I'll keep the same object closer to the eye. Same 2 centimeter object. Now I'll keep about a gap having a 3 centimeter. Earlier gap of the object and the eye 10 centimeter. The new gap is only 3 centimeter. Then what will happen? As usual, as earlier, let's get a light ray which goes through the optical center. Now, what has happened to the size of the image? The size of the image, the size of the image formed on the retina is now larger. So, a larger image is formed on the retina. So, it means the size of the image formed on the retina does not depend on the size of the object. I have used the same object. It completely depends on this angle. The angle subtended on the eye by the object. Got it? So if we use the linear magnification equation saying height of the image divided by height of the object is the linear magnification, it's not a good, better measurement, right? But if you consider the angle subtends on the eye, you get a very accurate answer. When this angle is larger, you get a larger image. It means you will able to see the object in larger size. For example, if you take a pen, if you keep it closer to your eye, you will see it in larger size. At the same time, if you look at an aeroplane which is moving far away from you, you will see the size of the aeroplane smaller than the size of a pen, because the pen subtends a larger angle on the eye, so you will see the pen as a larger object. The aeroplane which is at far away from you subtends an angle, smaller angle on the eye, therefore your eye will observe the aeroplane as a smaller object. Therefore, the size of the image seen by an eye depends on the angle subtended by the object on the eye. So in the exam, no need to draw the figures, but if you draw the figure, you can easily explain. So it will be easy for you to explain and earn marks by drawing figures in the exam. So start 1995 AL light essay question, draw these two figures quick. Size completely depends on the angle subtends on the subtended by the object on the eye. Even if you get a larger object, if that object creates a smaller angle, the image seen by the eye will be a smaller one. So if you want, you can argue that distance also a factor, but directly you can discuss, you can explain the size by considering the angle. No need to worry about the distance. So this is the answer for the first question. So I would like name it as Roman number 1. So it will be easy for me to give answer. So I'll take this as Roman number 1. Roman number 1 says angular magnification is a better measure compared to the linear magnification in determining the magnification produced by an optical instrument. Briefly explain the above statement. Optical instrument means a microscope or a telescope, something like that, right? So please write the size of the image formed on the retina. The size of the image formed on the retina depends on the angle. The size of the image formed on the retina depends on the angle subtended by the object on the eye. The size of the image formed on the retina, the size of the image formed on the retina depends on the size of the angle subtended by the object, by an object on the eye. The size of the angle subtended by an object on the eye. By an object on the eye. Full stop. If an object creates, if an object subtends a larger angle on the eye, if an object subtends a larger angle on the eye, a larger angle on the eye, comma, a larger image is seen by the eye. If an object subtends a larger angle on the eye, on an eye, if an object subtends a larger angle on an eye, comma, a larger image is seen by the eye. A larger image is seen by the eye. Therefore, angular magnification is a better measurement. Therefore, angular magnification is a better measurement. Okay? Right. Let's go to Roman number 2. A student constructed a refracting telescope using a cardboard tube and two convex lenses of focal length 100 centimeter and 20 centimeter. He observed the image of a distant building with the telescope in normal adjustment. So telescope is in normal adjustment. Calculate the magnifying power of the telescope. Derive any formula that you may use. That's the point. The telescope is in normal adjustment. They ask us to calculate the power, but before we calculate the power, they ask us to prove the equation that you use. To prove an equation, we have to draw the ray diagram. We have to prove the equation. After that, we have to use the equation to obtain the power. Can you understand it? So that's why I have said you should practice drawing ray diagrams. You should practice to prove the magnification equations. There are about 10 ray diagrams in light lesson. They will ask at least 2 of the ray diagrams in the examination. So please practice to draw ray diagrams. Right, here we have to draw the ray diagram. We have to prove the equation. Then only we can find the angular magnification. So if you do not draw the ray diagram, you can't prove the equation. If you do not prove the equation, you can't find the angular magnification. If you memorize the equation and substitute the value and calculate the magnification, you get some marks, but not the complete marks because you have not proved the equation. So therefore, practice to prove all the equations and practice to draw all the ray diagrams that I have taught. Clear? So I have covered the syllabus earlier. I have taught you the light lesson earlier. Now you have more time before the exam to practice drawing the ray diagrams and proving the equations. So I have done my job. Now it's your time to do your job. Right. So I'm going to erase. If you want, please get a screenshot. I'm going to erase the things that I have drawn on the board. Right. They have said it's a refracting telescope. Refracting telescope means normal astronomical telescope. An astronomical telescope or a refracting telescope is constructed by using two convergent lenses. One lens has a larger focal length, which is said to be the objective lens. The other lens has a relatively shorter focal length, which is said to be the eye lens. You keep your eye closer to the eyepiece lens. The objective lens is focused to the object. That's how we use it. Right. Look at board. Look at board. Let's give a try to draw the ray diagram. Right. I'll draw the principal axis. I'll draw the objective lens. So what is this here? And this dotted line indicates the objective lens. Right. I'll mark the focal length of the objective lens here, saying capital FO. Right. The light rays coming from a distant object. It is said a distant building. It means object which is at a far away from the telescope. So when the distance between a telescope and object very large, it can be assumed that light rays coming from the object are parallel to each other. Light rays coming from the object are parallel to each other, but they may not be parallel to the principal axis. This red color horizontal line is the principal axis. Right. So let's take two light rays coming from the object like this. So we don't know the place where the two light rays meet with each other. Due to the convergent lens, they will meet somewhere, but we don't know the point at which these two light rays meet. To find that point, we do something like this. We draw a dotted line through the focal point. Then we take an imaginary light ray like this. Let's say this is the first light ray is AB, the second light ray is CD, and the third imaginary light ray is EF. The theory here is, the logic here is AB parallel to CD and CD parallel to the imaginary light ray F. The EF light ray meets at this point. This dotted line which is drawn through the focal point, and the EF virtual light ray, imaginary light ray, meets at this point. They meet at here. Then the other two light rays will also meet at the same point. That's the logic, right? So let's say this is D, let's say this is B, so I can erase. This light ray will go through this point, and this one will also go through that point, right? So this is the place where the first image is formed. So I can mark the first image here. So H1 is the height of the first image, which is produced by the objective lens. So after that, we have to draw the eyepiece lens. We have to draw the eyepiece lens, right? So when a telescope is in normal adjustment, the focal point of the objective lens and the focal point of the eyepiece lens both should be at the same point. What's the theory here? When a telescope is in normal adjustment, focal point of the objective lens and the focal point of the eyepiece lens should be at the same point. Therefore, this distance is equal to the focal length of the objective lens, and this distance is equal to the focal length of the eyepiece lens FE. And should carefully measure this distance. For example, if this distance is 4 centimeter, you must measure a same 4 centimeter length and mark the focal point there. Got it? So best thing is I have to move the lens a little bit to this direction, so I can shorten the focal length, right? Then I don't know the path followed by these two light rays after they travel through the eyepiece lens, right? Please draw the figure up to this. After that, I'll explain how to complete the ray diagram. Complete this part. After that, I'll tell you how to complete the rest of the ray diagram. Start. Right, so I have repeatedly taught you this light lesson, right? You should be 100% okay with the light lesson, right? If you face any difficulty drawing this ray diagram, send me a message or please ask me, I can help you. Send me a message after you have drawn the ray diagram here, because I have drawn only the half. I have to complete the rest of the ray diagram, right? Right, look at board. How to draw the rest of the ray diagram, how to complete the rest of the ray diagram. The easiest thing is, let's take a virtual light ray which is parallel to the principal axis. Let's take a virtual light ray which is parallel to the principal axis. That will go through that will traverse through the focal point. And let's produce it backward. So what have we done? We have taken a virtual light ray from the first image, which is parallel to the principal axis. It will travel through the focal point. Similarly, let's take another virtual light ray which travels through the optical center. The light ray which goes through the optical center is not bent, so you can produce it back. So it can be clearly seen that the two rays are parallel to each other. Therefore, we produce the other two light rays also to be parallel, and we can produce them back. So finally, all the four light rays, the two real light rays and the two virtual light rays, all of them are parallel to each other. So this is the complete ray diagram. Complete it and mark two angles on the ray diagram as alpha here, this angle alpha, and this angle beta. This mark two angles alpha and beta. Alpha is the angle between EF light ray and the principal axis. Beta is the angle between the principal axis and the light rays going through the optical center. Mark alpha and beta angles, quick. Right. By looking at this triangle, you see H1 is the height of the opposite side, and if naught is the length of the adjacent side. Opposite side of alpha is H1, adjacent side of angle alpha is F naught. Right? So we can write an expression for tan alpha. Tan alpha equals opposite side H1 divided by adjacent side F naught. H1 over F naught. But this angle alpha is very small. This angle alpha is very small. It means it's less than 10 degrees because the object is at far away from the telescope. So we can write that tan alpha approximately equal to alpha. But here you should remember that this angle alpha must be kept in radian. When an angle is kept in radian, if that angle is less than 10 degree, tan alpha value and the value of alpha in radian will be equal. So if you consider these two equations, we can obtain a single relationship. So I'm going to erase this side of the ray diagram. So if you were not able to draw the ray diagram, please get a screenshot. I'm going to erase that side because I want more space to write. Right, look at board. So I'll erase. Now, what are the things they are here? Tan alpha equals H1 over F naught, tan alpha equals alpha. It means alpha should be equal to H1 over F naught. Mark it as the first equation, right? Tan alpha equals H1 over F naught, tan alpha equals alpha. Tan alpha to tan alpha equals, therefore alpha equals to H1 over F naught. Mark it as the first equation. Complete. Similarly, I'm going to write tan beta. If you consider the angle beta, H1 is the opposite side, FE is the adjacent side. So tan beta equals opposite side divided by adjacent side. So it means H1 over FE. So we can write tan beta equals, by looking at the small triangle, opposite side H1 divided by adjacent side FE. Similarly, tan beta approximately equals to beta because beta is very small. So tan beta equals, therefore beta should equal to H1 over Fe and mark it as the second equation. Complete. So like this, you have to draw the ray diagram and prove the equation. Right, I'm going to erase the complete ray diagram. So if you want any more time to draw the ray diagram, please get a screenshot. Please get a screenshot. I'm going to erase. Right, so the ray diagram is disappeared. Right, so what is the angular magnification? Angular magnification. Angular magnification of the telescope when it is in normal adjustment equals beta divided by alpha. Equals beta. I use this symbol for the division, right? Beta is given by the equation H1 over Fe. H1 over Fe divided by alpha. Alpha is given, sorry. Beta is given by H1 over Fe. Alpha is given by the equation H1 over F naught. H1 over Fo, objective length. So then H1 over Fe division becomes multiplication when you take the reciprocal of the two terms. Then you get F naught over H1. Now see that H1 and H1 cancelled out. Finally, we get the angular magnification as F naught over Fo over Fe. This is the final equation for the angular magnification when a refracting telescope or an astronomical telescope is in normal adjustment. We have drawn the ray diagram, we have proved the equation. Now we can use the equation and find the angular magnification. Then we are able to obtain full marks for the question. Right? Start. Right, I'm going to erase everything that I have written on the board. If you want, please get a screenshot. I'm going to erase everything. Right. Angular magnification of a telescope when it is in normal adjustment, we have found it as focal length of the objective lens divided by focal length of the eyepiece lens. Focal length of the objective lens 100 centimeter. Focal length of the eyepiece lens is 20 centimeter. 20 centimeter. Right? So now you, what do you think about the units of angular magnification here? Centimeter to centimeter cancelled out. So there is no unit for angular magnification. It is only a number. Right? So 20 to 20 cancelled out. 100, so the centimeter cancelled out. 100 divided by 20 is 5. So angular magnification is 5. Complete it. Right, now let's go to the next part of the question. Right, so I have given more than enough time. Right, what is the next part of the question? Later, he has converted instrument into a terrestrial telescope in normal adjustment. So terrestrial telescope means it is used to observe objects on the earth. Normal adjustment means the final image should be formed at the infinity. It means the final light rays coming out from the eyepiece lens should be parallel to each other. So final image is formed at the infinity means the light rays coming from the eyepiece lens should be parallel to each other. So it is believed that parallel light rays meet at the infinity. So we believe then the final image is formed at the infinity. So when a telescope is in normal adjustment, final image should be formed at the infinity. Therefore, light rays coming from the eyepiece lens should be parallel to each other. Parallel light rays will meet at the infinity. So final image will be at infinity, right? Terrestrial telescope means it is used to observe objects on the earth. So it means if you use only two lenses, as in an astronomical telescope, objects will be inverted. Image will be seen like this. So it means if you use a normal astronomical telescope with two lenses to observe a human, you will see the human like this. Human will be inverted. That's the case. So to overcome this problem, this student uses another convergent lens and he is going to place the lens somewhere in between the first two lenses. Let's read the question further. Later, he has converted the instrument into a terrestrial telescope in normal adjustment by placing another convex lens of focal length 8 centimeter between the objective and the eyepiece, while keeping the distance between the objective and eyepiece as short as possible. So you must identify this sentence, while keeping the distance between the objective lens and the eyepiece lens as short as possible. That is Roman number 3. Under that they have asked 4 questions as simple A, B, C and D. I'll read simple A question for you. Why it is convenient to use the arrangement mentioned in Roman number 2 over the one given in Roman number 1. It means why this method, why using a third lens, why it is convenient, why it is easy to use the telescope with the third lens which is kept in between the two lenses. Then by using the third lens, you can get the image, final image will be erect. So this human will be able to see like this. So this is the thing done by the third lens, right? So it's comfortable for our eye to see a human like this than this. So this is said to be inverted. This is said to be erect. So Roman number 3, simple A question, please write. When the third converging lens is used, final image will be erect. When the third converging lens is used, the final image will be erect. Final image will be erect. So that's the reason, right? They ask why it is convenient. Simple B question. Read simple B question. I have given the answer for simple A. Simple B question. What is the distance between the image formed by the objective and that formed by the lens of the focal length 8 centimeter? To answer that, we have to draw a ray diagram. Let's go to the next question also. Simple C. The path, trace the path of two rays coming from the top of the building through the terrestrial telescope to the eye. So it means they have asked us to draw the ray diagram with the third lens. So once we draw the ray diagram, we can answer that distance question, right? To answer distance question, we have to draw the ray diagram. So let's give a try to draw the ray diagram. So I'm going to erase everything that I have written on the board. Right, look at board there. So I want a large space to draw the ray diagram, right? So this is the objective lens. Objective lens, right? I'll mark its focal length, focal point to be here. Let's say FO, right? Then I'll take two light rays coming from the distant object. They are parallel to each other. I'll draw two light rays coming from the distant object and they are parallel to each other. So as usual, I'll draw a light ray. I'll draw a dotted line perpendicular to the principal axis through the focal point of the objective lens. Then I'll take a virtual light ray which is parallel to these two light rays, these two light rays coming from the distant object. The virtual light ray means the red color dotted line here. Therefore, the other two light rays should also go through this point. So this one will go through this point, and the other one will also go through this point. Right. So the first image is formed here. Right. H1. Even though we put the third lens in between the two lenses, we want to keep the gap between the two lenses in the shortest possible way. So the third lens is needed just to invert the image, just to change the image, but not to increase the size, right? So look at board here. Let's say this is for example, let's say this is the 2f of the third lens, 2f. And this is the focal point of the third lens. And let's say this is the third lens. This is the third lens. Got it? This is the third lens. So this distance is simple f, 8 centimeter. This distance is also f, 8 centimeter. F means 2f. When you know that when an object is kept on 2f of a converging lens, right, you get its image on the 2f of the other side, right? These two light rays incident on the lens, right? So I have to measure this f distance. I have to measure another f distance. I have to mark 2f here. Clear? Again, this distance is f. This is also f. When an object is placed on 2 of f, its image will be formed on the other 2f. The magic is if the height of this one h1, height of this one will also be h1. There is no change in the height. Now we have inverted, and now we are able to keep the distance between the two lenses in the shortest possible size, right? So as we are we are so sure that height of this one and height of its image are same. So we can just measure this height and mark the image here. These two light rays should go through this image. So therefore, just join them by using a ruler like this, right? Light rays coming from the object. First image is acting as an object for the third lens. Third lens produces the second image, right? So as the object is on, this is an image, but it is acting as an object. As the object is on the 2f of the third lens, its image will also be formed on the 2f of that lens. There is no change in the size, right? So after that, we want the final image to be, listen carefully, please wait, don't draw. We want the final image to be at infinity. To get the final image to be at infinity, the light rays coming from the eyepiece lens should be parallel to each other. So if you want parallel light rays from a converging lens, you must keep the object on the focal point. If you want to make the light rays, these two rays to be parallel to each other, you should keep this object. Look at board. You should keep this object on the focal point. So therefore this is 2f as well as this is 2f as well as it is the focal point of the eyepiece lens. Can you understand? 2f of the third lens and the focal point of the eyepiece lens should be at the same point. Now there's an image. That image is acting as an object for the eyepiece lens. That object is kept on the focal point of the eyepiece lens. Therefore, the final image will be at the infinity. Please draw the ray diagram up to this point. After that, I'll further explain and I'll complete the rest of the ray diagram. Start. Send me a message saying done once you have completed the once you have drawn the ray diagram. So this is objective lens. This is eyepiece lens. This is the focal point of the eyepiece lens. Therefore, this distance is equal to Fe, and at the same time, this is the focal point of eyepiece lens as well as it is the 2F point of the third lens, right? So if you are confused with this simple F distance, I can mark that simple F distance here, like this, F, like this. Right. First image, second image. I want to obtain the third image. The easiest thing is, let's take a virtual light ray which is coming from this image. So I'll take a light ray which is coming through the optical center. So this is a virtual light ray coming from this image, right? A light ray which goes through the optical center is not bent. And we know that when an object is kept on the focal point, the light rays coming from going through the lens will be parallel to each other. Now they will be parallel to each other and they will be parallel to this dotted line straight, this dotted line. So the final path followed by these light rays will be like this. Finally, these three light rays, all these three light rays will be parallel to each other. When you draw, please clearly indicate that they are parallel to each other. So please clearly indicate that they are parallel to each other. So this is the complete ray diagram. This is the complete ray diagram. Once the third lens is inserted in between the two lenses, and to keep and to have the minimum distance between the eyepiece lens and the objective lens. Then we can answer that question. So what is the question that can they have asked? The distance between the image formed by the objective lens, and the image formed by the third lens. They have asked us to find that distance between the image formed by the objective lens H1 and the image formed by the third lens. So we should find this gap. So that is F plus F plus F plus F. It means how many F's are there? F plus F plus F plus F. It means 4F. So this is 4. F is given as 8 centimeter. F is given as 8 centimeter. 4 times 8 means 32 centimeters. So that is the answer. To obtain that answer, we have to draw the ray diagram. We have to draw a ray diagram. Otherwise, it's difficult for us to find that distance. Okay. Right. So if you are not able to do the ray diagram, it's better to get a screenshot. Right. So I have done my job very well because I have completed up to the light lesson for my 22 AL students. Right. And these days I'm teaching heat lesson for them. So we'll be able to cover the syllabus so early, then we'll be able to do more questions. So your life will be successful. You'll get a good result. The next question that they have asked us to find the distance between the objective lens and the eyepiece lens. So as I do not have enough space, I'll erase this part, but not the entire ray diagram. Right? If you want, you can get a screenshot. Right, let's find the distance between the objective lens and the eyepiece lens. Look at board. This is the objective lens. This is the third lens and this is the eyepiece lens. So look at board. So this is the focal point of the objective lens. Therefore, this is equal to F naught. F naught, F, another F, and Fe. So the answer is the distance between the objective lens and the eyepiece. The distance between the objective lens and the eyepiece equals F naught plus 1, 2, 3, 4F. F naught plus 4F. 1, 2, 3, 4F. Plus Fe. Right? So F naught is 100 centimeter, 4F is 8, plus Fe is focal length of the eyepiece lens, 20 centimeter. So then 4 times 8, 32. 132 plus 20 means 152 centimeters. Complete. The gap between the objective lens and the eyepiece lens after the third lens is inserted between them is 152 centimeters. Finally, they ask the new angular magnification. To have a change in magnification, size of the images should be changed. The third lens with the focal length of 8 centimeter does not change the size of the image. You see, this is H1 and this is also H1. So it has not changed the size of the images. Therefore, the angular magnification remains unchanged as its previous value. Previous value of the angular magnification is 5. Therefore, the angular magnification remains unchanged as 5. No units. Right? Put the question number properly and write. The third lens with the focal length 8 centimeter. The third lens with the focal length 8 centimeter. The third lens with the focal length 8 centimeter does not change the size of the image. The third lens with the focal length 8 centimeter, comma, does not change the size of the image. Does not change the size of the image. Size of any image actually. Therefore, the angular magnification remains unchanged as 5. Therefore, the angular magnification remains unchanged as 5. Got it? The third lens having the focal length 8 centimeter does not change the size of any image. Therefore, the angular magnification remains unchanged as 5. Got it? Right. Today I have discussed the first structured essay equation, first essay equation, and the light essay equation of the 1995 paper. I'll send you a homework that is the second structured essay equation given in 1995 paper, which is given from the mechanical waves, oscillation and waves lesson. I have already completed it. So at home, try to do the equation and send me your answers, right? I'll send the photo of the question to your WhatsApp, right? I think that's enough for today. I think you have enjoyed very well, right? So that's enough. See you. Good night. Bye.